In this video, we solved a numerical of rectangular and triangular weir. Means it is the combined numericals of rectangular as well as the triangular weirs. So first we understand the problem statement. Water flow over a rectangular weir and dimension of this rectangular weir is the 1 meter wide at a depth of 150 mm, and afterwards it passes through triangular right angle weir. Means first the water is flow from the rectangular weirs, and from the rectangular weir it is supplied in a one triangular right angle weir. Means triangular right angle means the theta is 90 degree for a triangular weir. Taking CD for the rectangular and the triangular weir as 0.62 and 0.59 respectively. Means CD is different from rectangular. Means CD for rectangular weir is the 0.62 and the CD for the triangular weir is the 0.59. And find the depth over a triangular weir. Means for a triangular weirs we need to find the H. But here that is a two weirs are there. One is rectangular, second is triangular. So here we consider it is the H1 instance of the H. Now we write down the given data. First we write down for a rectangular weirs. So length L for a rectangular weir is the 1 meter. Second, depth of water H is given, it is 150 mm. So 150 mm divided by 1000, then we get the in a meter it is a 0.15 meters. CD for rectangular is the 0.62. Now other data is for a triangular weir. So first data is given here the right angle weir. Right angle weir means the theta is equal to 90. So here we mention theta is equal to 90. Second CD is given. CD is the 0.59 for a triangular weirs, and we need to find out the depth of water for a triangular weir. So it is denoted as the H1. So when we derive this equation separately for rectangular triangular, it is the H. But here they are mixed. That's why for a triangular instance of the H, we can denote it by the H1. So how we calculate it? So first we need to find out the Q for a rectangular weir, because for that all this parameter is given. That is the H is given, CD is given, okay, and this Q is same for a rectangular weir as well as the triangular weir, because the triangular weir is connected with the same canal, means the same discharge coming out from the rectangular, so both have the same Q. So then after, by using this equation of the Q for triangular weir, we can find out this H1. So first the discharge over the rectangular weir we can find out by using these equations that we already know. That's the Q for a rectangular weir is the 2 by 3 into CD into L under root of 2G into H raised to 3 by 2. Now we putting value of all these parameter. CD for rectangular is the 0.62, L is given, that is a 1 meter, into under root of 2G, that is 2 into 9.81. So unit of G is the meter per second square. Okay, so when we consider G is 9.81, then we need to put the L as well as H in a meter. Otherwise your answer is in a wrong units or value is also wrong. Into H. So H is the 0.15 meter or a 0.15. So here we putting this value of H. Then we solve in a calculator. Then we are able to get the answer of Q for a rectangular weir. Q is equal to 0.10635 meter cube per seconds. So this is the discharge for rectangular weirs. Same discharge is passes through a triangular right angle weir, but discharge Q is given by the equation. So we already know that the equation of the Q is different for rectangle as well as for a triangular notch. Now for a triangular notch or a triangular weirs, the equation of Q is this, that is 8 divided by 15 into CD into tan theta by 2 into under root of 2G into H raised to 5 by 2. Now Q is same for both. So we put this the value of Q that we already calculate. The Q is equal to 0.10635 into 8 divided by 15. CD for the triangular weir is the 0.59 into tan theta by 2. Value of the theta is the 90 because it is given right angular weir. So it is a tan 90 divided by 2 into 2g into h1 raised to 5 by 2. So instance of h we can replace, it is the h1. Now then further we putting this value or simplified that the 1045 means here 90 divided by 2, it is a 1045. So 1045 is equal to 1 and under root of 2g, so value of g is 9.81. So under root of 2 into 9.81 we get this answer, it is a 4.429 into h raised to 5 by 2. So we need to calculate this h. Now further we multiply this all the value in the calculator, we get this answer, it is a 1.3936 h1 raised to 5 by 2. Then after this 1.3936 is supplied in a left side, then it is go in a divide portion. h1 raised to 5 by 2 is equal to 0.16, sorry, it is 0.10635 divided by 1.3936. So we simplify this or we calculate, we get this answer 0.07631. Okay, so this is the value of h1 raised to 5 by 2, but we need to calculate this h1. So what we do, we supply this power on the right side. Okay, then it is converted in a reciprocal. So this value has the power of 2 by 5. Or also we can simplify that we can multiply both the side with this power of 2 by 5. So here 2 and the 5 is cancelled. So here only the h1 is remains. Okay, or we can also take that this power is supplied on the right side, then it's converted in a reciprocals. So h1 is equal to 0.07631 raised to power is the 0.4 means 2 divided by 5, it's have the power of 0.4. Then we get this answer, h1 is equal to 0.3572 meters. So this is the h for a triangular weirs. So here we can compare the same quantity of the water is passed from rectangular weir and the triangular weir, what is the height. So for a rectangular weir the h is equal to 0.15 meters and for a triangular weirs the height is the 0.35 meters. So thank you for watching this video. If you learned something, then like the video and subscribe my channels for watching the more video related to FMHM as well as other subject of mechanical engineering. For FMHM various link is provided in descriptions as well as in car. For other subject I request to visit the playlist and don't forget to share with your friends.